this question is asking us to make a quartic polynomial with real roots at x equals -2 and x equals 5. So if we apply the factor theorem, we know our factors are x plus 2 and x minus 5 because they're always the opposite sign. Now we also know that our quartic is x to the power of 4. And we have 1, 2, so this would end up being x squared with our real roots. So we need to multiply it by another factor of x squared plus or minus something that's going to give us a complex root because we're only allowed these two real roots. So if we have x squared plus or minus something equal to 0, how do we make that complex? Well, this ends up having to be negative because the square root of anything negative will result in a complex number with I in it. So x squared plus 1 is the easiest to multiply out, so that's the one I'm going to use. However, you could use x squared plus any number you like. And then it's just a matter of multiplying them out. So I'm going to start with the first two brackets. So I get x squared minus 5x plus 2x minus 10. I'm going to neaten this up because they are like terms. So I get x squared minus 3x minus 10. And this all has to be multiplied by our x squared plus 1. So I'm going to start with my x squared and multiply that out. So I get x to the power of 4 plus x squared, and that one's done. And I get negative 3x cubed minus 3x, and that one's done. And I get negative 10x squared minus 10, and that one's done. Okay, so now I'm going to neaten it up by collecting the like terms, and I end up with x to the power of 4 minus 3x cubed minus 9x squared minus 3x minus 10, and that is the quartic that the question is asking for.